for today. So yesterday we got into really the foundational components of data science, and what's nice about that, not data science, DevOps. And what's nice about that is we're ready to kind of go to the next level, which is learn about DevOps. There's a little bit of material that I wanted to just wrap up pretty quickly. I'll only spend maybe 15 minutes on it, which is automating text and file system. And then what I want to do is move on to the other parts, which are, how to do continuous integration and do continuous delivery, and how to have this operational mindset. So to start with, then let's move over to this notebook again, which is in this Colab directory. And one of the things I like about Colab notebooks is, from a teaching perspective, is that you can see here that I can just scroll through and look at this whole presentation and find whatever section I'm working on. I'm going to navigate over to automating text and file system, and I'm going to pop over to that section. So one of the things that does come up a lot with any kind of an automation process, and that's really what DevOps is you're going to need to work with files at some point. And in particular, I think one thing to be aware of with working with files is that there's some ways to do it that are slightly inefficient, and there's some ways to do it that are very efficient. And so first, let's just go through a very simple use case here where I go ahead and I open up a file, and I call it workfile.text, and I make it writable with this flag. And I can just put little bits of text in there, right? I can say f.write, and I can put this in, and I have to manually close the file. And then if I use that little trick that Chris was just talking about, where I can cat it by using a Unix command, I can see that, yeah, it created some stuff inside there. And if you want to see if I change it, like if I want to change this to, foo21, right, it'll slightly tweak that, and now I have a slightly different file. So that's okay. And Python is fairly succinct. Maybe another way you would write it would be, you could do this. You could say my writes, and you can say foo2, foo3, foo4, and you can say open workfile.text and say for line in my writes, f.write. So this is probably more likely the way someone would write something. Again, they would go back to what we talked about yesterday. You have this container, I like to call it like a basket. You have a basket, you put some stuff in there, and then you pull stuff out of the basket, and then you go through and you write this. But even this has got a little bit of a problem in that it's really easy to forget to do this, which is f.close, and then all of a sudden your program is not writing to disk, and that could really be a problem. And so the Python core developers came up with a neat little trick here, where what you do is you write to a file with context. And so if I go here and I say with open workfile.text and make it writable, I say workfile.write and say, and put a piece of text in there. And look at this, this is only 2 lines of code. And so this is really the recommended way to write a file with Python, is you use this context, and it implicitly knows to do the right thing, essentially. And there's other kinds of context for networking and things like that. But in general, this is the recommended way to write a file in Python, is say with open, put that into a variable, and then just say workfile.write. Now, if you want to read a file, you can also go through here and put a read statement together, doing the same thing, f.readlines, and then remember to close it. But that also has some problems. What if you forget to do a close? You could get errors, and you can also use that same nifty trick here, which is with open workfile.text, and then go through and write that out. So there's some huge advantages to using context for reading and writing files. Now, the files, one of the problems with a file, though, is it's not necessarily efficient to save things in a way that's easily serializable. So, if I want to put something that's more Python centric, like we talked about dictionaries yesterday, that's a core data structure in Python. That's one of the foundational pieces to building applications. If I wanted to write it out to a file, I'd have to unpack it and do all this stuff. And I think in some cases, thinking about serializing data is really a much better approach by using native Python data structures and then putting those native structures to disk. And that's really what pickle does. So if I go through here and I just make a really simple dictionary, and then I say import pickle, and then I do pickle.dump, what I can do if I go and I list this is that I'm actually just taking that dictionary and putting it right onto disk. And what's nice about this is, look, if I go here and I say pickle.load, I can load that dictionary right back up again, and then I can print it out. So there's two really incredibly good use cases for this. So one of them is, imagine that you are new to a company, and I've worked at a lot of enterprise companies, Fortune 10 companies, Fortune 500 companies, where they don't give you access to anything for a while. Like, it can be very cumbersome to get access to a relational database, to get access to the file system, to get access to all kinds of things. But you want to do well at your job. You want to make an impression in your first 30 days. And so how do you save data? Well, one of the ways you could save data is that you can directly write the data to a dictionary and then just save it to disk. And especially for data science workflows, I think this is really handy. Or if you're investigating some kind of an error on a system for DevOps, is if you're able to just save it, pickle it out, and pull it back in again, you can keep making forward progress without needing to get permission to be successful, right? And so that's one use case. The second one is that with machine learning, and I do something like this in the repo I shared yesterday, the Python MLOps cookbook recipes, is that you can actually serialize the machine learning model itself by pickling and then pull it back off of disk. So this is an important thing to be aware of, and you can see it's trivial. It's really just one line of code to dump it. Now, another format that is very DevOps friendly here is a JSON dictionary. I'm sorry, a JSON data structure. And JSON stands for JavaScript Object Notation, and it is actually a really useful format to save things in. And if you notice here, I can just take that dictionary, save it out, and if I print it, it's fairly human readable. So even if someone's not a programmer, you could probably show them a JSON file, and they're like, oh, okay, yeah, I kind of understand what's happening. Especially if it's a very simple dictionary, it's like, oh, here's a key, here's a value, maybe these are customers and the customer name or something like that. And what's nice about this is if you save things as JSON, then it's really easy to convert your code into a microservice, which we covered yesterday is a DevOps best practice. And so I personally love this method of building services out, and I'll save things as JSON. And then later, if I want to build a command line tool, or I want to build a web application, then it's trivial because I've already saved a lot of the intermediate files as JSON. So that's just an important thing to be aware of. Another format that's very DevOps friendly here is YAML. And YAML stands for yet another markup language. And with YAML, one of the things that's interesting about it is that most of the cloud-based systems that we'll get into today in a little bit use YAML for configuration. And so you can see here that it's basically a dictionary or JSON, but it's slightly more human readable. So this is even more friendly, where if you wanted to do rapid prototyping, for example, for an application, and you didn't want to build a UI, and you wanted to just go for speed, maybe what you could do is you could create an intermediate format where you save everything as YAML, and then you give it to maybe the product managers of your company, or maybe business people, and just say, look, as long as you put it into this plain text style format with YAML, I can take your work and we can kind of start rapidly building something. So that's one of the advantages of YAML, is it's widely adopted in cloud systems, and also it's probably friendly enough that you could even give it off to users who maybe are not programmers. And now to load it, pretty simple as well. I can do that with context thing here and then load it up. So those are just some of the things that I think could be really helpful, and they're very simple to do in Python. So let's kind of scroll down here to this. I'll only go through this really briefly here, which is managing files and directories using os.path and pathlib. So there's a new method in Python, I think it was Python 3.7, which is pretty new itself, that there's a library called pathlib. And what's neat about it is that it combines a lot of things that typically were in separate libraries. It's now like a centralized library. And so you can see here, if I say import pathlib, I can say pathlib.path, make directories, parents true, exists okay. And basically it can kind of do everything all at once, right? So I can define a path, it can create the directories, and also check if they exist. So it's a very comprehensive solution here. And then if I look at this, you can see that it actually did create that directory. You also can go through here and do things like check for paths, whether they exist. And these are kind of, I would say, bread and butter DevOps kind of things, is dealing with the file system. If I want to see, does this path exist? Oh, it doesn't exist. But what about the second path? We know that that does exist, right? Because I created it up here earlier. You can also write text directly from a path, which is pretty incredible, actually. So you can basically create this variable that is this object that can, have an association with something. And then you can do all these things like check if it exists, write text to it. So it's a neat little alternative to the method I showed you before of writing text. This might actually even be cleaner, right? Because it's just one line of code. Another thing that you can do here as well is that you can even rename files. So again, this is another really canonical style thing you would do with DevOps, is you need to maybe create a backup script or something like that and rename things. Well, you could go through here and say from pathlib, import path, p.open, go through, check it out, rename it, and notice that what'll happen is that you can see this is before the rename. We've got this foo, new file, work file 2, work file, and then it goes through and it renames this thing to be bar. So really straightforward to rename. All you have to do is take a pathlib object. It's already got that method associated with it. And if you remember from yesterday too, I talked about this, that one of the great things about Python is if you take any object and you do dot inside of Colab Notebook, it shows you every possible thing that you can do. And so look, rename is just on here, right? Rename is basically one of the things that we can do. Is right. Yeah, there we go. Rename. But and any of these three-dimensional boxes here are things that do work. And so you can see I can do things like open things. I can figure out I can change permissions. I can figure out what are the stats, the Unix file stats. I can check if it's a symlink. So this is really a powerhouse type library that really is a one-stop shop for doing anything with the file system. So it's worth playing around with here and doing things out. You can also do things too, like, for example, look for absolute paths, which I need all the time when I'm writing scripts. You can figure out the current working directory. So in a nutshell, try out the pathlib library. You'll probably like it. And then there's other ways of doing things in Python. fn match is an example. If I want to look for matches for certain files, this comes up a lot if I want to write a little utility that searches things. If I want to, for example, archive data, I think this is probably something that is not widely known. That's incredible in Python, is that you can say from shutil import make archive, and this will create a gzipped archive of some directory. And so if you had to do this yourself with bash, it would be a very messy bash script and really hard to maintain and really confusing. But you can create a backup script in just a few lines of code by using this shutil.makeArchive utility. So really nice library to play around with. I didn't want to get into doing this because this is a temporary environment, but definitely would recommend playing around with how to create your own backup scripts. And then, as always with any backup, I would recommend that you do automated restores. If you don't test automated restores for backup, you don't have a backup system. So the other thing that you can do in Python that I'll kind of just go through really quickly here, and this is also really common, is that you want to walk a file system and you want to see what's on that file system. And so really the style to do that would be something like this, where you say import OS, you say os.path, import join, get size, and then you get the root, the directories, and the files, and you just go through and you walk through and you do something to it. So how would we do this? Here's an example. If I go through here and I use that same style, and in fact, this will work in your Colab notebook, is you say import OS from os.path, import join, get size, and you can kind of walk through and do anything. So you could use any of the things that we covered yesterday or today, and then do things to those files, right? Rename them, move them, zip them up, whatever it is that you want to do data science on them, change permissions. So here's another example as well, which is getting information on files and directories. So if we go through here and we say, import OS, results, look at the globally, look at the group ID on it, look at the size on it. You could actually start to crawl a file system using these techniques and actually look for maybe wrong permissions, or look for certain files that are certain size. There's a lot of reasons to do these kind of actions on a file system to maintain it, make sure it's healthy. Another thing that comes up a lot in DevOps is this concept of monitoring and instrumentation. And one way to do that is to have health checks. And so let's say that you were building a system that needed to, let's say, provision certain assets. When I worked in film, I had a decent part of my life where I worked at Disney and Sony and Weta Digital, is that a very common thing in film is to programmatically create trees of files and then give those, maybe movie files to different editors, and they can do things with them. And a lot of times you get the wrong permissions, or there's some kind of an error. And so you could write a health check where you could look at the permission by using the stat, and then verifying that a file system, when it's created, it actually has the correct permissions. And so this is just an example of how you could do maybe proactive monitoring to make sure that you're not creating a mess when you're automating the creation of trees of files. Another thing you can do as well is you can actually wrap up existing Unix and Linux utilities that you may be really comfortable with. A lot of people like to use the find command, for example. Well, you could wrap that in a sub-process, and you could actually kind of get the best of both worlds, which is maybe you already have a ton of experience with the find command, all the the bells and whistles. Well, you could just put that into popen here, put the find command in here, get some user input, and then allow someone to kind of use Python and find the same command. Also, there's one other tool that's kind of similar. There's glob is another one that you can use that's kind of handy, like if you want to look for certain file types in a directory. And again, you could combine that with that other method earlier that walks the file system as well. So that's pretty much what I wanted to cover in terms of the file system. I just want to just briefly give you those examples. You can play with them on your own. And then I want to move on to the next two topics, which let me just briefly whiteboard those out here. So this is, I think, maybe the most important aspect of modern software engineering, machine learning engineering, and DevOps is something called CI/CD. And in particular, with CI/CD, one of the things that's important to think about is the center of the universe is the build server. And it's often not discussed enough how important really a build server is for CI/CD. So CI stands for the basically automated testing, and then make it testing here. And then the D stands for delivering the software. And so with DevOps, this is a must-have, not a nice-to-have. This is a must-have in terms of building something, is that you should have your code automatically tested. And once it's automatically tested, it can be automatically delivered. And at the center of this is the build server. And one of the things to be aware of is that in terms of build servers, there are a couple styles of build servers, or let's just say there's 3 styles of build servers. The first one would be open source, and we'll just say OS, open source. And probably the big one here that most people would use would be something called Jenkins, right? And Jenkins, it has some advantages in that it's free. It works on all platforms, Microsoft, Windows, Linux, OS 10. I've actually created environments that use all three of them at the same time. So it's a really, really useful option. The downside, though, is that you have to actually manage it yourself, which can be a little bit cumbersome. And so, there's trade-offs to it. The second style, which is what we're going to cover today, is the SaaS style build server. And with SaaS, really there's a couple options. I think Circle CI is a pretty popular option. And then there's also GitHub Actions. And that's what we're going to use today. Is we're going to use GitHub Actions. And there's a lot of things to like about GitHub Actions. And the reason that I like it so much is that it's just the pace of innovation of features that they're building. And so GitHub Actions in particular really nails the testing aspect of things, like, really well. And then there's a third style, which is called cloud native build servers. And the reason why this comes into play in a DevOps context is that my recommendation would be is if you are deploying to one of the clouds. So if you're deploying to AWS, you're deploying to Azure, or you're deploying to GCP, that you should use the native cloud native build server to do your DevOps workflow. And the reason for that is that they have all kinds of hooks and tricks that are built into there that'll make your life easier for both testing and delivery. Now, you could use both as well. And so I would also recommend that that's not a bad strategy, which is that you do continuous delivery and testing with the cloud native server, like AWS has one called Code Build, but also maybe for just generically, just testing your software, why not use the great innovation occurring with GitHub Actions and have it, basically make your code better by having a feedback loop. And this feedback loop is something I call Kaizen, which is just a term for continuous improvement that came from the Japanese automobile industry. And the reason why the Japanese automobile industry has really been a good example of this is that post World War II, they did a lot of work on making systems that are continuously better, right? And in fact, we see this from the cars that have been created by the Japanese automobile industry were incredible, and they're some of the best brands in automobiles because they have this idea of, I want to make things better, I want to automate things. And so the same thing applies with testing. Is really the goal here is to remember that that it isn't a static system, it's a dynamic system software. And it's your goal is to create a automated process that can continually make things better. And a few different people have reached out to me since the last presentation and said, how could I, get started with DevOps, or how could I, kind of specialize on something that would make myself have the highest probability of getting a job or having a good career. And I would say this is that if you're a specialist on CI/CD, that you're one of the most valuable people in an organization. And so it's a little bit like the expression, which I don't know if I agree with, but you can never be too thin or too rich, right? That's kind of a silly expression. It's kind of the same thing though with continuous integration, continuous delivery. You can never have too much testing or too much automation, and you can constantly make this thing better by going through and improving your software. So that's exactly what we're going to build. Is from zero, we're going to build out a GitHub repo. We're going to set it up with GitHub Actions. I'm going to go through and create a Python scaffolding. So let me just also walk through what I'm going to create with you. So what we're going to create is, I would call this like a recipe for a good project. And so here we go. We'll just say Python project recipe. So if you want to have a successful project that is DevOps compliant, you'll need to do these things. And so in order to do these things, the first thing is we'll create a GitHub repo from scratch. And notice that GitHub could be anything. It could be whatever source control provider you want. And then inside, I like to create a scaffold that has a few different little tricks in there that make me successful. So one of them is that I would create a makefile. That's part of the scaffold. And the makefile is where I store all of my commands. So it's almost like a cookbook where I would refer to it, and I don't have to, like if you're making pancakes, for example, sometimes it's annoying to go, wait, what do I have to do again? Like, do I need 2 cups of flour or 1 cup of flour? So you look at the cookbook, oh yeah, it's 1 cup of flour. So it's kind of the same thing. A makefile just keeps track of these things that are annoying to keep track of. We'll also have a requirements file, and the requirements file will be the where all the packages are kept. And then we'll also have an app. So we'll just build like a command line tool real quick. And then we'll have a test file. And the test file will allow us to test out our application. So really, this is the 4 components of a project that are essential. And then once you've got this set up, then you can hook this up into the build system. In this case, we're going to hook it up into GitHub Actions, and then you can get this continuous feedback loop. And what's great about this continuous feedback loop is its goal is to make things better, right? Like continuous improvement by automatically testing things. Every time I make a change to my software, I can go through and make things better. So let's go ahead and build this out. So step 1, what I'm going to do is I'm going to go to GitHub, and I'm going to create a new repo. So let's go ahead and go here, and let's create a new repo here. Go to repositories, say new, and we'll call this, DevOps best practice. There we go. And what I would recommend when you're creating this is, put a description. This is an example of a DevOps repo that conforms to best practices. There we go. Got this created here. And then I would always add a README file, add a gitignore file. And what the gitignore file does is it makes sure that you don't accidentally check in files that are kind of like wasteful or garbage files. And then we can go ahead through and create a repo. Once we do this, what's neat about this particular setup is that I can easily now start to build it out in some environment. And I talked about this yesterday, that the golden path, or an environment that already has things kind of protected for you, is the best way. And there's really a couple different ways that we can do this. I'm going to show you first a really an emerging tool called Codespaces. And then we're going to move over to AWS Cloud9. So I'll just only spend a little bit of time with Codespaces, just so you can see what the future is probably going to lead to. My opinion is most people won't be developing on their workstations anymore. They'll be developing in a web browser. And so if we go to, this is a beta feature that you can ask for permission to get access to. So if you go to GitHub, you can say, hey, I want to be on the beta list. But let's go ahead and take a look at this. I'm going to click on Codespaces. And then I'm going to, let's see, delete this, one of my code spaces. I'm going to create a new code space, and I'm going to say the name of what I just created. We'll call this DevOps. I think it was DevOps best practices. There we go. And what's nice about this is Codespaces will just clone everything and put it into a virtualized environment. And so this is, in a way, it's kind of the equivalent to Colab Notebook, but for like a development environment. And I think probably in a year or two, a lot of people will be using this as their primary form of development. So we can see here that we've got some, stuff here where I can navigate the file system. And if I go through here, I can say, which Python 3, and we've got Python 3 set up here. We can do Python 3. We can see that it's 3.385. So got some great integration that we can play around with here. So what I would do first here is I always create a virtual environment when I first start to work in a location. So it's got built in here virtual environments. There's two ways to invoke it. It depends on which environment you're in. Either they've got this tool installed, which is virtual environment, or it would be Python 3-m venv. I'll show you both methods because we'll do the other one with Cloud9. So if I go through here and say virtual environment, I can say tilde/.venv. I like to put my virtual environments in a hidden file, hidden directory inside of my home directory, because I don't want to accidentally check them in somewhere, and it's a good convention to follow. So we go through here and we do that. So Python virtual environment, and then I just need to activate it. So I go source here, .venv, bin activate, just like that. And we'll make this a little bit bigger. There we go. So once I've got that, now I can install all my packages that will go into that directory, and it really protects me from a lot of weird things that happen. And so that's just a thing to be aware of, is always create a virtual environment when you're dealing with Python and source it so that you don't get these weird edge cases when you're developing code. So the next thing I'm going to do is I'm going to create these files. So I'm going to say touch makefile, touch requirements file, like here, .txt, and then touch, let's say app.py, and then we can start with that. We can start with those three things. So the first thing here is that I've got a makefile, I've got an app, and for this, let's just make it really simple to start with, and we'll just say print hello. And if we want to run this, I can go through here and I can say Python app.py hello world. And for the makefile, though, the pieces that I like to put inside, I can just copy this from I have a lot of different examples of this, but here we go. PyTest GitHub Actions here. I'm going to go to this file here, and I'm just going to cut and paste this in. So I'm going to grab this stuff and throw it into this makefile. And so this is what I pretty much do this kind of a style on most of my projects. And let's walk through each of these sections. So the first thing I do here is I have an install command, which does pip install, and it upgrades pip because pip always needs to be upgraded for some reason. And then I install things that are located in this file. Next, I have a test section. In this case, we can change this to app, right? Because we're going to build something called app. And then I also have a format section that formats my code, because a lot of times it can be really helpful to format your code so that you're complying to the Python standard practices, like it's called PEP 8. And also I lint the code. And then in this case, again, we'll change this to the app. And all this does is that it uses the library called linter. And I tell it, I don't want to know about annoying warnings here because they're too verbose, but I want you to fail the build if there's an error or a warning. And this is really helpful in that you can use this as a quality control check for your software. So there we go. We got install, test, format, lint, all here. And now that I've got this set up, the only really thing I need to do here is go to requirements and put a few packages in. And so to start off with, I can do pylint. That was one of them. We're going to use click later, so I'll put click in there, which is a command line tool library. Also, pytest is another one. And let me just look at the makefile here. Do I do? Yeah. So pytest and black, which is the formatting tool. So there we go. Let's go ahead and let's do make install here, just like that. All right, so now that we've got this set up, I could, in theory, do make lint and it should pass. Now, if we want to see it fail, what we would do is we could just put like some bad code in here, put like a variable that's, doesn't declare a value, right? That's syntactically incorrect. We do make lint, it fails. So this is an instant feedback loop without me even needing to write tests. I've got a good quality control check that's local to what I'm doing. So what I'm going to do now is I'm going to check all this in. So I'm going to type in get status, and there's a make file, app file, requirements file. Let's go ahead and add these in. So we'll say get add, get commit, and say adding initial scaffolding. There we go. And let's go ahead and do a get push. And this will push it to our environment here. And so if I go back to GitHub, let's just go make another tab here, go back to GitHub. We should see DevOps best practices, DevOps best practices, that those files exist. Great. And I can kind of edit them and play with them. Sometimes I'll do that. I'll edit things inside of here. So now that we've got this set up here, I'm going to abandon code spaces and I'm going to move over to Cloud9. So again, this is, I think, a really awesome environment to code in. It's in beta, so not everybody has access to it yet, but it's worth knowing that this is going to be coming. Now I'm going to move to the cloud-based environment. And so I'm going to shift gears to AWS here. And what I'm going to do is I'm going to use a service on AWS called Cloud9. And it's very similar to GitHub Codespaces. And if I go through, just to show you from the beginning here, if you have a free tier account, you can use Cloud9 for free because there's a free offering for it. But basically, you just type in Cloud9 or you click on a recently visited service, and then I can say create environment like this. And again, we'll do the same thing. We'll just say DevOps best practices here and put some information so I can remember it. This is my core AWS environment for doing development. And we go through next here, and a couple things that are really awesome about Cloud9. I would recommend when you first get started, just leave everything default. But just to let you know here that this is a free environment. So basically you can develop things and 1 gig of RAM and 1 CPU is plenty for most software development. And essentially you can use it for free. It gives you the exact operating system that Amazon is running in their servers. So I would recommend as well, just again, using the defaults. And then this is a really neat little trick, is that by default, Cloud9 will auto hibernate and save everything. So it's kind of designed to be cost effective for you. So you won't be being charged a bunch of, fees. And so it's essentially like a very efficiently designed environment for developing cloud native applications. So if we go next step here, I can just go ahead and create this. And it takes, I would say, all of maybe probably 30 seconds or so to create this. Now, the other thing that we'll need to do, one of the advantages of GitHub Codespaces is that it already has all the GitHub SSH keys and everything set up for you. So you don't have to worry about, setting all those things up. We only have to do one slightly different thing here, which is that we have to create SSH keys, and that's it. And that's really trivial. And you only have to do that one time, the first time you create an environment, which is pretty nice. So again, we'll just give this a second to kind of wake up here. And while that is waking up, one of the things that I'm going to do is I'm going to go to my profile here, and I'm going to go to settings, and then I'm going to go to SSH and GPG keys. And then I'm going to say new SSH and key right here. And so we'll call this AWS best practices DevOps or whatever. And then if I go back here, it's all woken up, which is great. And I've got this nice environment here to kind of play around with. So the first thing again that I would do is create a virtual environment, and we also need to create SSH keys. So let's first create the SSH keys. I'm going to type in SSH keygen -t RSA like this, SSH keygen -t RSA. We'll do return again, and then this will put those files into this directory. And all I need to do is take that path, copy it, do run the cat command, which just prints it out, and just print that out to foreground. So it's the pub one. And if I copy this whole piece of text, I can go back to SSH keys, paste this in, and then confirm my login, and then that's all I need to do. And now it's ready to go, and I can now check out that code that I was working on earlier. So I can go back to this repo and go to that DevOps best practices. Here we go, DevOps best practices, and I'm going to click on code icon here. And this is another easy place to get tripped up, is don't use HTTPS, because it'll ask you to authenticate with your username and password, which is really annoying. Instead, click on SSH once you've got the SSH key set up, and then click on copy. And if we go back here, I can type in git clone, and now I'm able to authenticate, and I got the code that I worked on earlier, which is awesome. And then if I double click this, you can see that it's actually got the ability to edit files. So it's a really incredible development environment that AWS has made available. And also, my opinion for doing cloud computing development and DevOps is that you should use this as your first option. And the reason for this is that it's already got the hooks and integrations for you to do more advanced things, like do serverless computing, build command line tools, interact with interfaces inside of AWS. And I think we might be able to hook into a little bit of AWS stuff today. We'll see how far I get. But in general, if you're using AWS, my opinion, you should use AWS Cloud9. So we've got this thing set up here, so that the first thing I'm going to do, as I mentioned before, is create a Python virtual environment. With Python, there's really two styles. On AWS, you can use the virtual environment module. So Python 3-m venv. I'll do the same thing. I'll say tilde/.venv. So it's going to create this kind of external directory here that's hidden in my home directory that will be the virtual environment that I'll use. Once I've create this, I then source it here and do venv bin activate. Now I can actually even document this really easily by just copying this like this, and I can put this into the README, and I could say, set up a venv, and then I can go through here and I can put in triple quotes to do a this is a code block here. And then if I save this, I can test that my feedback loop is working with even editing documentation. So we'll do git status here. Well, first I need to change into the directory, and then do git status. And you can see that it says, hey, you have a change to the README file. Let's go ahead and add that. And we'll commit it. And one little trick here, it will say adding info on venv, is that the first time that you set up a new system, that it'll ask you to configure your Git environment. And I typically like to do this so that you don't have weird users in your environment, so that you can keep track of stats. And so this is a nice to have. You don't have to do this, but I like to do it so that I know you kind of what's happening. So you just put in your whatever email address you want to associate with this, and then you amend it, and then that's it. And then you can put this change in here, and then do git push, and then there we go. So I've got this set up. What's the next thing that I can start to build out here? So probably the next thing that I can really briefly start to get into before we take questions. Actually, no, we should probably just take some questions right now. And then we can start to then go to phase 2 after questions, and then build out the continuous integration and command line tools, and maybe even a little bit of AWS stuff. So, but yeah, let's dive over to questions here real quick, and let's see what we got. So first question is, how long before, okay, so answer live, how long before O'Reilly releases Python for MLOps? Yeah, so we're still working on it. I would say probably June would be the final release. And if you go to this repo here, Practical MLOps, you can get a lot of the source code for it. So basically you can just kind of play around with it here and get a lot of the pieces of code for it. So next question, Python is known as an interpreted language, but I read that it also can be compiled language as well. Can you explain that? So with Python in particular, maybe I'll just put this into a directory here. So Python is an interpreter. It's a scripted language, and one of the problems with Python in particular is that speed is a real issue in terms of Python. And so one of the ways that you could resolve that is you could potentially compile Python into more of a machine level code. And so a couple ways that you can do that is they have something called Numba. And what Numba does is it uses a JIT, or just-in-time compiler, to basically take Python code and move it to assembly, right? So you can basically bring it at the machine level by just putting a decorator on top of your code. And so if you want to check that out, you can just go to Numba. You just go to the Numba website. If I go here, Numba, go to their website, and they have a lot of documentation here that goes through it. You can just, again, just say just-in-time compiler. So that's probably the most prevalent and realistic way to compile your code to a new format. That it isn't the only way. There's also people that are using this thing called PyPy, which is a Python compiler for Python. And that's also can do speed up improvements. But basically, I would say this is probably the most predominant way that people would compile Python into another language, because you can just add a decorator, and then it'll move certain things, especially if it's NumPy related, directly into machine level code. Also, Numba can do GPU programming as well, and so you could compile it down to a GPU instructions using the CUDA SDK. So I would probably say those would be the main places to focus on doing that in Python. Okay, next question here would be, what's the difference between using import or use? I often see use to load a module. Yeah, that's a great question. So really let's just say Python importing here. So with Python importing, what you're doing really is just taking a file, and the file could be lib.py or whatever you want to call it. And when you say import lib, basically what you're doing is you're importing the stuff that's in that file. So in that file, you could actually have something called hello. And inside of hello, you could then access it by saying lib.hello and then calling it. And so that's really all it is you're pulling like a function or a variable or something from another file. And you can do that by doing lib. Now, if you want to say use, you can also say from lib, you can say import hello, and you can do that, and that you can directly access it. Or if you want to use, you'll see this a lot. Someone will say import pandas as PD, right? So and that's all that does is just make it a different name, an alias. So those are the main ways that that people import things in Python. Okay, so next one here is, what are the limitations with cloud native continuous integration? So I would say that's a great question. So limitations of limitations of CI for cloud native. And I would say one of the limitations here and we'll call this cloud native limitations, is that if you look at GitHub, one of the reasons I like it so much is if you look at the culture, like if you look at the culture of GitHub, who is their customer? It's a developer, right? So they really think about developers, and they have a feedback loop with GitHub where they're a developer and they're building tools for developers. So they're building, awesome stuff. So that's really their goal. And so they build really good things that make you more productive. For a cloud provider, it depends on what cloud provider in particular. AWS is pretty good at this in that you're the customer, and in fact, they're really customer focused. If you're dealing with a research oriented cloud like GCP, they're really good at research. So things like Kubernetes, they're really good at things like TensorFlow. Like, for example, AWS doesn't have TensorFlow, but what they're weaker at is the customer, because in some sense, they're building things where it's either they're using customers as the product in the case of search, or they're doing research. And so sometimes the testing and the kind of the bells and whistles with a cloud provider can be weak, right? And so that's really the thing, is you'll get weaker testing tools or weaker tools that are outside of what they're doing. And that's why I like to use a little bit of both. That's a great question. Here's another one. Can requirements stipulate version numbers of modules? Yeah, so with requirements, for example, if we go through here, one of the things that you can do is that you can actually do this. You can type in pip freeze. And in fact, I think we need to do, let's go ahead and in this cloud environment here, I don't know why it's frozen for a second. Let me just refresh it. So if I go to this cloud environment and I say make install, let's go ahead and install the software. This is how I would recommend doing the version numbers, is that first get it working, make anything work. And then if you go to the requirements file here, what we can do is we can swap out these names here for whatever was the package that I installed. So if I type in pip freeze, it'll show me the different version numbers. So I can just literally cut and paste these. So take PyTest, there we go, put this in there, and then go to Python Black here. Where's that? Okay, there we go. This is this version, great. Throw that in there, go to click, okay, great, take this one, copy this, throw it in there, go to PyLint, take this one, go here, perfect. And so now I've got the specific version number. And I think this is a good idea for many reasons to have specific version numbers, because it's very common that libraries change. And so if you're going to give someone documentation, or you're giving a portfolio piece, or you're putting this into production, having a specific version number will prevent it from really having untested changes that go into production. So then if we want to change this, pretty easy. I go through here and I say get status, and I say get add requirements, commit this, and then say adding version numbers. So yeah, this is a less known trick to be aware of in Python. Great question. So another question here has, GitHub has an IDE environment. Does GitHub or AWS environment just show to have a hook to use an IDE for the Git commands? I don't know. I think yes, actually. I haven't played with it yet, but if we go to source control, I think that if I change a file here, let's see, touch, readme, or let's just add a thing to the readme file. I literally have never done this before, but let's just see here, like, test, add this. Let's see, there we go. Yeah, so it does have an IDE. So that's another advantage. I'm glad you told me about that. I've never used that. Great question. Okay, did you see C Python will be more popular or there? Okay, do you see C Python will be more popular than standard Python or any advantages to using C Python? So yeah, I would say with C Python, if you mean Python, for example, uh, I think just regular Python, in my opinion, is probably the going to have the most adoption because it serves the most purposes. So I don't think any exotic flavor of Python will ever beat the standard version of Python. Okay, another question here is current market and trending cloud jobs. How do you transition from current IT software pre-cloud into a position? Is it possible for mid-career? What should be the plan? Yeah, that's a great question. So basically the question here is okay, so you're an IT professional, and how do you go from zero, right, to cloud? So I would say we'll call this 0 to 1. There is definitely a way to do this. So the first thing I would say is that most of the resources that I have available, I've actually put them onto Skillsoft as well. I have several books on there, but you can also go to my website and there's a bunch of free courses, bunch of free material. Everything in my GitHub is all available as well that you can take a look at. And in particular, what I would focus on is I would start with, again, the biggest cloud provider. So I would go to AWS solutions architect certification and/or cloud practitioner. They're pretty similar, and I would get that one done. Get it as quickly as possible. Kind of knock this one out. That's step one. Step two is the stuff I'm doing today. I would make sure that you master everything we're covering today, which is CI/CD and everything we covered yesterday. Really, this minimal path of Python, and make sure you can do CI/CD for Python, and then know a little bit of things like how to use, let's say, AWS Lambda, which I'll be able to do a little bit of that today. I think this is really the way to go to 0 to 1. Is this is the most impactful thing that you can study, and realistically, you could probably get all this stuff done here within, I would say, 6 months. Is a good way to do this. By the way, I also have a free course on Coursera that you can go to that goes into a lot of this that I did with Duke that covers a lot of the same material as well. So those are the resources I would use. And I would say, and again, all the stuff on Skillsoft, there's a ton of amazing resources there. Solutions architect, CI/CD for Python, do a little bit of stuff with AWS Lambda. And then I would build what I call a triple threat. And so the triple threat is that you have a certification, which is what we just talked about. You have a portfolio, and then you have either a degree or job experience. So either one. So you could the degree could come in some form of like a MOOC, right? You could just get a certificate, maybe this Coursera course, or you could get a degree at some other program, or just get some experience somewhere building something and put that on your resume. And so really that's it. That's the formula to go from 0 to 1. And I know this because many of my former students have gotten jobs as machine learning engineers, DevOps engineers, using this exact same formula. Great question. And next question. So how did the requirements TXT packages get into the virtual environment? Okay, so the way this works is that if I go back to here, is that notice that this file here is just a list of packages. And so notice this make file, it's creating an abstraction that runs the pip install command. And the reason I'm doing this isn't to hide things or make it like tricky, is to make it simple so that these are really annoying commands to have to run, right? It's like, oh no, pip install -r requirement. Just a lot of, you see how many times I make mistakes when I'm typing. So if I just type in make install here, if I type in make install, that this will just abstract all that for me. And then the only other thing that I did was I typed in pip freeze, And what all pip freeze does is it tells me the current installed version, and then I can go back to my requirements file and I can lock it in. So that's it. Those are the steps to do that. So a question is it worth to study Chef? I personally would say no. I would study a newer infrastructure as code. I don't think I would say it's neutral, basically. I think more likely the current infrastructure as code offerings are either Pulumi or Terraform or Cloud Foundations, which is part of AWS. All three of those would be my recommendation versus Chef. Okay, another question is, what place does package manager take in CI/CD toolchain? So the idea, that's a great question, for where does packaging take place? So the idea with CI/CD, and again, we're about to get into this in a second, is that you're testing not only the code itself by logic, but we're also testing the ability to do syntax, and that's what the linting tool does, and also installation. And so basically the build server, which is again kind of a good segue, installation. This is a great segue because we're going to test all three, 1, 2, 3, by doing the CI/CD. So this is probably I'm gonna come back to these questions, and I'm gonna move on to setting this up, and then we'll come back and if you keep putting the questions in Q&A, I'll answer them after I set this up. But this is perfect segue. Let's get this thing set up. So we got this thing ready to go here, but we don't have this automation hooked into our system yet. So how do we do this? Well, what we can do is you can go back to GitHub Actions here and notice that there's a section called Actions. You can just click on this button, and then you can say, oh, what do I want to do? I would recommend later play around with some of these other things you can do, like you can deploy your code, you can build containers, you can set up continuous integration, all kinds of things for other projects. But for now, we're just going to click the default one. And then I'm going to go back to my examples here. I have one for already. I can just copy, called GitHub Workflows. And I'm going to copy this and I'm going to just paste it in. And if I copy this, we can go here and we can just paste this in here. And notice what this does is that, that's weird. I wonder why I got to refresh this. Let's go ahead and do that. Okay, so let's go ahead and paste this in here. Delete this. We'll paste this in. Give me a second. My browser was kind of flaking on me for a second. Maybe I'll just refresh one more time. Let's just refresh a couple times, clear the cobwebs. Okay, so go through here. We take this, we delete it, I paste this in, and then hopefully, I think I need to, maybe I didn't cut and paste this whole thing correctly. Let's go through here again and do it again. So copy this. But basically, I'm copying. I don't know why that's acting weird in previewing, but I'm going to do it a different way. I don't know why this is acting weird here, but basically, you just need to create a GitHub directory. So I just need to recreate this, and GitHub will be smart enough to create this. So I'm going to create this. I'm going to create a .github directory and a .workflows directory. So I'm going to do that. I'm going to type in make-dir-p .github, and then also workflows would be next. So let's go ahead and do that. Workflows. All right. And then once I've created that, I just need to, inside of there, create a file. So go ahead and we'll do this. We'll do GitHub workflows, and we'll call this main.py or main.yml, like that. And once I've got this, then I can paste this in here. I don't know why the browser was acting weird there, but basically this is just a YAML file that says make install, make test, make lint, make test, make format. And again, what's awesome about this is that it can allow us to uh, kind of go through and test many different things about our code. So does the installation work? Does the linting work? Does the testing work? Does the formatting work? And so I'm going to go ahead and save this. And then I'm going to say get status again. And it's going to say, oh, you added some things. Let's add the README. Let's go ahead and add the GitHub here. And let's go ahead and commit this, adding actions. And then once I've set this up here, I go back to my project, which should be the DevOps one here. Oh, what's the wrong repo? We'll go to this DevOps best practices repo. And if we click on this and I click on actions, you'll see that it's actually building. And this really is an incredible service from GitHub. We can just look through step by step, and it shows me all of the awesome things that I've already set up on the project. So it's testing that my packages and the pin versions work correctly. It's testing that the linting works. It's testing the PyTest. So, look, we have a failure here. Notice that it says when I ran PyLint that you have invalid syntax, which we do. So if we go back to this code here, notice that I had that problem, right? We have a problem here. So let's kind of just clean this whole thing up, and let's actually copy some code from some command line tool project I have. I think I have a few. Here we go. Click cookbook. This might be a good one. I'm just going to copy this exact code. So this is a piece of code that's kind of a fun little piece of code here that calculates the correct amount of change. So if I put in an amount in here, it'll tell me, whether I should have 4 quarters or 3 dimes or, whatever. And then I use the click library here that is putting a decorator on top that says @click command, @click option, and it takes that piece of code and it passes in amount into it. And then all I need to do is get the results and then print out what the correct change is. So this is, I think, a pretty good kind of hello world style piece of code that really builds on everything that we covered yesterday. So I'm going to go ahead and grab this whole thing and I'm going to copy it. And then I'm going to go to my environment and I'm just going to swap this out. Here we go. And notice that, again, we can see the whole thing in here. We've got click, we've got the change, everything. So I can run this. One of the nice things about click when you use it is you just need to say import click, put your logic somewhere, and really this decorator, these 2 decorators, click command and click option, do all of the magic. And then I just have to orchestrate what happens. And then underneath, I put a little stanza here that says, all this says is it's a convention in Python that says, if I run this as a script, invoke that function, which invokes click. So the other thing I need to do here as well is make it executable. So I'll say chmod plus x app like that. And then if I run this, we can see that I can type in -help and it will give me a help message, which is pretty cool. So I get all this stuff for free by using the click library. And notice that it prints this out, basically give correct change. So it looks like a real Unix, command line tool, like a really fancy one. And I wrote almost no code. That's why I like the click library. So if I go through here and I say app and I say amounts, let's go ahead and see what the proper change is for $1.34. We print this out. And look, the other thing I do is I actually use it in click called style, and it will actually print different colors for me. So it says, here's my change for $1.34, 5 quarters, 1 nickel for pennies. And I can do, other values as well. There we go. For $1.39, 5 quarters, 1 dime, 4 pennies. If I do, I don't know, $11.39, 45 quarters, 1 dime, 4 pennies. All right, so awesome. I got this thing working. Let's also build out the test code for this as well. So I'm going to just, again, grab it from this cookbook here and go to test. And notice what I do. In order to write a test in Python, really simple, is that I just need to say from an app, import something, and then assert that this value is equal to what's going to come out of it. So I'm going to go ahead and do that as well. I'm going to do in this here build out a test file. So I'm going to say touch test app.py. There we go. Go ahead and throw this in. And here we go. We got our change. And now that I got this working, I can type in make test. And if we go to the make file here, all it does is just run the Python test command, which is pytest. And all these do is they give you more verbose output. So let's go ahead and run make test. There we go. Test pass. Awesome. We're ready to go. If I type in make lint, now lint should work. There we go. Lint works. And in fact, I can type in make all, and make all will do the installation, it'll do the linting, and it'll do the testing. So we're really in great shape here. And if I type in make format, this will format my code and it'll make it look a little bit cleaner. There we go. So really we have an awesome feedback loop here that allows us to set up the next step, which is full continuous integration. So let's go ahead and do that. Let's go ahead and say, get status here. Here we go, get add app, and then test app. There you go, get commit, adding working CI. Okay, and now if I push this, I can go back to this repo, click on actions, and we can see that, it failed before, but hopefully it works this time. But let's see, maybe it's not working this time. Let's see here. I don't think, maybe it's not woken. Oh, there we go. I was like, it seems like it should be working. So if we click on build here, we can just watch it in action. And so it's going to go through those series of steps that we told it. First thing is it tests it with Python 3.8 and installs the dependencies. Really, so this is testing the version numbers that we hard coded in there, which is really important part of the DevOps process. Once this is passed, then it'll go to phase 2, which is it'll lint our code, and then that passed, which is great. And then it'll go through and it will test our code. And so we see that, again, we can look through here, our code has been tested, and we can go through and we can format our code. And then we see all those things passed. And so what I can do as well to make this kind of a little fancier is you can create a status badge. So I'm going to go ahead and click this, create a status badge, copy that status badge, and then I'm going to go back to my repo here, and I'm just going to paste this in at the top. So here we go. Let's just paste this in at the very top here. And then what's neat about this is if I save it, that it will show me that my code is passing. So this is a good idea for a portfolio project, is to basically let people know that you care enough to build tests for it, and that you're actually testing your software, and they can click on this and see everything that's happening. A couple of the things to point out here about GitHub Actions is that you can actually do all kinds of things with GitHub Actions, including you could, for example, test multiple versions of Python. Let's say you're building a library that's an open source library, and you want to test it for Python 2, Python 3, Python 3.7, Python 3.8, Python 3.9. You could do all that with GitHub Actions. You can build containers. You can do continuous delivery. There's just no shortage of things that you can do with GitHub Actions. So I definitely recommend kind of playing around here and doing more stuff. Now, let's add a couple more little bells and whistles here to this project. Another thing that I like to do when I'm doing testing is that I like to use a library called pytestcov. So I'm going to install it first. So we'll say pip install pytestcov, and then I'm going to do pip freeze again, so I can find out what version was installed. And we'll find pytestcov here, and we'll throw this in there. Right. And then I can actually tweak things in my make-file to take advantage of test coverage, which will show me what lines of code are passing. So I'm going to go back to my cookbook, which I think I had this in for click. Python click cookbook. And if I look at the make file here, notice what I do is I say pytest cov report missing. So I'm going to go through here and I'm going to paste this into my make file. I'm just going to slightly tweak it. So it says, continue to do test coverage or testing, but also I want you to generate a coverage report and show me if I'm missing anything. So let's go ahead and take a look at that. And if I type in, basically make all here, right, which will install everything, test everything, lint everything, we should be able to see what's going on. And so now note that it says that actually there is some things missing. And so it says lines 37 through 41 have some problems. So if I go back to my app here and we see that, well, what are we missing here? So notice that lines 37 through 41 are all of the invocations of click itself, right? So the logic is tested, but click itself isn't tested. So if I cared about that, which maybe I don't, but if I cared about that, I would need to do a little bit more to test the invocation of click itself, basically, essentially like a functional test of click. So how would I do that? Let's again go back to this cookbook here. And I think I have an example of this in, let's see, the DevOps repo, actually. Let's look at this DevOps course repo. I believe that I put an example of, yeah, so we want to use click test runner. So let's go ahead and do this. So let's go through the test file here. And let's say from click import test runner. And we want to do basically a runner that will invoke the command line tool for us. So I will want to build something that kind of looks like this. So I'm going to go ahead and just copy this and tweak it a little bit. So basically, we're going to say test. App, and we're going to say we've already imported the one thing from the app, but we'll need to import as well the tool that invokes it. So if we go back here, we want to import make change as well. So I'm going to go back to my test file here, and I'm going to say, let's import make change as well, right? So let's import app. Let's import change and make change. I mean, there's a couple ways to import this. I guess if I'm lazy, if I don't want to do this, I can also just say import app, and then I can do app.change. This is probably a little cleaner, app.change. And then here, I will test my app. I'll have a click runner. I'll invoke it, but notice I need to change this to be amount. And then I also want to change this to be $1.34. And then we can assert that the command line tool doesn't blow up on us. That's really what this does. And also we could assert, like if we run this thing again, like I think I can just look at the output of one of the commands. Let's go ahead and assert that. Let's actually do the exact command that basically the word we'll assert that this appears in the output, basically. So we can build a functional test here. Now, what are we missing here? Invoke. Oh, it won't be tokenized. This is nice, as the syntax highlighter shows us some cool stuff about how to debug our code, essentially. So I'm going to go through here and I'm going to say I want to do app.make change. There we go, make change. And there we go. And I believe that's everything. And let's format our code, right? So that make sure our code is nice and clean here. Kind of look, you notice it's pretty nice. It kind of cleans things up here. And if I type in make test, it should have a much higher test coverage. There we go. So we see now that we're only missing line 46. And I would say this is a fool's errand to try to get 100% test coverage. That's good enough. That's close enough. we're able to test the command line tool, and we're able to test the logic of it. That's pretty good. So again, we can kind of go the next step here and say get status, make these changes in by saying get add star, go ahead and push this. So I'd say get push, or actually first I have to pull the changes because I added the badge, right? So it'll want me to pull those changes in, then I can do a get push. So that happens a lot, is that it's easy to forget that you made a change here. So if we go back here, we should be able to go to action, and we should see a new change. Did I not push that change? Update README 7 minutes ago. Let's go ahead and do get status here. Oh yeah, so I didn't push those changes. So I need to do get commit. So get commit, adding new test, and we'll do a get push. There you go. So now once I push the change, it'll trigger the events. This will take me just a second here, and then it'll trigger off a new build. What's nice about this is that it's real time, so I don't have to worry about doing anything at all. It's completely automatic, and we're able to watch this thing build. There we go. Perfect. We see the test coverage report. So really, this is what I just showed here is, my opinion, mandatory for every single project that you would ever do. You should do this process. It's very simple. It's easy to repeat. It's easy to share with other people. And then later, when you get into the deployment phase of things, which we don't have time to get into today, but you could actually add a deploy step. So let me show you, if we are going to move things to the next level, there's a repo I have called Elastic Beanstalk. Let's go to my repo here that really shows what you can do as the next phase here. So if we go to Flask Elastic Beanstalk here, I use the same style that I just showed you. Everything's the same. Now let's look at this and let's see what it does. So this particular repo is a Flask web service that, again, I use Cloud9 to develop. I did all the stuff I just talked about. And then I have all the same things, the make file, the requirements file. And then Beanstalk is a platform as a service offering. So it allows me to host web applications. I can build a Flask application here, and then I can actually deploy it using their cloud native build system called AWS Code Build. So, how would I do this, and how different would it look? It's pretty similar. Let's look at the makefile. If we look at this makefile here, notice that there's an install right here, similar. There's a test if I wanted to build a test. Lint, very similar. And the only other thing I do is I add a deploy. So it's trivial to do the CD part of CI/CD by just typing this command in, and this will deploy my application automatically. Now, how is that working? Well, we talked about this earlier, that services in the cloud often use a YAML file, and here we go. Here's exactly what it would look like. And so you can say version, this is, you could fork this exact repo, in fact, and get this working. But basically, I do a virtual environment, I source it, I do the exact same steps I did locally, make install, make lints, and again, you could do make test. This will fail if there's a problem, so it won't deploy it. But then if it does pass, then it goes through here and it does a make deploy. And then on AWS, this is something that's part of another service, which I'll show you real quick. We'll just go to the console. This is their cloud system, build system, which is called Code Build. And so Code Build allows you to do a very similar process. So you can see here, this would be a build process that went through and ran this. And all it is it's using that exact project, right? It's using that code and those settings to do the continuous build, and the trigger would be GitHub right here, and then the code itself to do the deployment. It's just this line of code here that allows you to do the deploy. So the application is trivial as well. Like it does almost nothing. This is a Flask application. So let me just show you a Flask application since it's so trivial and we got a little bit of time here. I'm going to grab this thing and I'm going to go back to our project and I'm going to say touch web.py. Let's try that. And then I'm going to just paste this in here and I'm going to go like this. And I'm going to do, what does that do? Unexpected indent. That's annoying. So let's first install Flask. So pip install Flask. And then I'll do the same thing. I'll do pip freeze so we get the right version. Freeze. And we can say Flask here. Let's grab it. There we go. Let's go to requirements. Let's paste this in here. And for whatever reason, I must have, okay, well, it went away. I don't know. Maybe it was a spurious error here, but I can actually add this to my linting as well. So I can say, I want you to lint not just the app, but I want you to also lint web.py. So let's just double check that this thing's working correctly. So Python web.py. Yep, it looks like it works here. And if I go to terminal, I can just curl this thing and say curl localhost 5000 like this. Okay, there we go. We see that it works. So basically this web app here, it can also echo the name as well. So I could type in echo Bob and it echoes Bob, Sally. But anyway, so we can go through and we can test this thing out. So this is kind of a fun little toy app that you could take a look at as well. And if I do make lint, which I was going to show earlier, linting works out. And so you can see how you could build out both web apps and command line tools. And we'll say this, we'll say git add, kind of add this thing in here as well, commit it, adding web. And then later you could turn this into a continuous delivery using any cloud provider. Really, this repo could be deployed to Google Cloud, could be deployed to Azure. If you want to see an example of Azure, I have one here that is in Azure Flask, and notice it's the same concept here. In this repo, Flask ML serverless, is I do a change event. I use their cloud native build server, which is Azure Pipelines. I deploy to their platform as a service, which is called Azure App Services, and I deploy this app. The same process where you just go through, you lint your code, you test it, you have the make file. Very, very similar process to build it on Azure. So once you know this pattern, really it's kind of like a building block that you can use to build out tons of different solutions. So just because I want to get to questions, the last thing that I'll tell you, though, is that we didn't really get into this, but one of the really awesome things about this Cloud9 environment is that it has implicit hooks into AWS. So notice that I could list every bucket I have on AWS just by typing in AWS S3LS. And that's one of the other advantages of the cloud-based system, is that I can, do stuff like that. The other thing I can do is if I wanted to start doing Python development for AWS, I could say pip install Boto3. And I could also do pip install of IPython. And I'll show you a little trick you can do as well here. And the way I like to test things out with AWS is that let's say I want to test out natural language processing with their APIs. I could type in IPython, which is very similar to Colab Notebook, but terminal based. And I could say import Boto3. And then what's great is that I don't need to set up SSH key, or I'm sorry, API keys at all. It's already talking to AWS. As I could say clients, we'll call this comprehend, which is their NLP service. And I could say Bodo3 .clients comprehend. And this will essentially allow me to do an API call dots. And remember the dot syntax here, right? Is that it'll let me do a auto completion, or it should. Dot. There we go. And we can look through all the different things that it can do. And I want to do detect. Let's do detect sentiment. Let's do detect sentiments. And then we can even do a question mark like this. Again, this thing we covered earlier, and it will tell me exactly the contract. And so all we need to do is put in language code and text string. Okay, let's go ahead and do that. So we can do text equals this is a beautiful day in Raleigh, North Carolina. And then I can also do language. I think it was language. We'll find out in a second. And then I believe that's all I need to do. Language code. So it said language code. And then I can put even that into a results object. And then I can go through here and we can see that in fact it says it's positive, right? So it's able to take my code. And I can also do other API calls as well. Like, for example, the other one was detect entities. So let's go ahead and try that. Let's say comprehend dots detect entities. And let's just do the same thing. Let's just paste that in there. And then I can start to build out command line tools, web services. There we go. It found Raleigh, North Carolina inside of there and was able to kind of go from there. So this is, I think, the other advantage of using something like AWS is that you can, Cloud9 you can kind of go into there. The other thing too is that, look at this tab here, is that it gives you access to their other services like container registry, AWS Lambda. And like the last thing I'll do really, really quick, because I got to go to questions, is that if I go to Lambda, I think this is the most Python friendly service that they have. And I would recommend playing around with it. And here's like the 30-second demo or 2-minute demo is I would go through here and I would say, let's go ahead and create Skillsoft Python demo, go to runtime, go to Python 3.8, and then I can just say create function. And then from here, what we can do is that I can just build out a really simple Python tool that later could talk to all kinds of things. It could be a web service, IoT service, voice service, whatever I want to build. I'm going to build just a really simple one though. And if I click on this, the one I like to build, this kind of a simple one, is we can do this. We can say, basically, if event name is equal to Marco. Again, this is the power of a function. Return back Polo. We already did this earlier. Otherwise, return back no, like that. And I can deploy this change. And then to test it, I could just put a phrase here, Marco, go here and say name here and do Marco. And let's go ahead and verify that this thing works. Create it. And it was saved. And now I can actually go through here and test it. And notice that it returned back the correct response. If I want to test it again, I can make another one called Bob. And then we'll put Bob in here, and then Bob should not work. And we'll go ahead and create this, and we test with Bob. It returns back no. So you can see, really simple to build these pieces of code that then later hook into triggers. And this is where you would start to build out like machine learning predictions, labeling things automatically that go into S3 bucket. And I do go into this in this repo, which again, maybe later I'll do this in another session for Skillsoft. But basically, inside of this repo here, I go through and I, if you go all the way down to this section here, AWS, there's a Lambda recipe where I build out a web service that does machine learning prediction using the same technique. So there's a lot you can do with AWS Lambda, and I would say that's probably the next thing that I would cover in terms of AWS. So a good place to take a break. I think there's a lot of questions teed up. Let me get to those questions. So let's see here. We are at okay, so next question is, what place does package manager take place? Okay, we already did that one. To what extent does data science need to master MLOps and DevOps skills? I would say that you should master it as, I think it's really an evolution, right? And I talked about that at the very beginning of this, is that we've got the lab or academics, and then we've got the real world. And even the academics that are doing science, biologists, eventually somebody's going to ask, where is it? And so in the real world, you must operationalize your work. And so I would say all data scientists must know DevOps, and all scientists should know about operationalizing their work, because eventually, in order to get paid or to maintain what you're doing, you need to put it into the real world. And it doesn't hurt, right? It doesn't hurt to know how to monetize the thing you're building or make use of it. And so I would say for all data science, you should do DevOps and MLOps. It's the next evolution of what you're already doing. Next question is, which cloud platform is based on the requirements? Which cloud platform to choose is based on requirements. Do you recommend AWS, Azure over cloud specifically for DevOps? I would say for, which cloud should you choose here? I would say that, I think I mentioned this a little bit earlier. I like to make data-driven choices. And so in terms of data, if we look at it, we know that AWS is number one. And so I think that's a reasonable assumption to make, is just stick with AWS, because they have the largest amount of, so if we just take AWS here, that AWS has a huge amount of offerings here in terms of the services. Also, it's going to be easy to find people to work on AWS, right? There's more talent that's out available, and then the cost is kind of reasonable. So I would start there, and I think it does everything you need to do. So there really isn't a reason to use another cloud platform, unless, for example, if your company has already some experience with Microsoft and you are using some of the Microsoft technologies. Why not? I think it's close to AWS in terms of the services, and it's got really large adoption for government. I know they have a big contract with them. If you're already doing C# development, yeah, why not? Why not use Azure? I would say Google is definitely more into the experimental category. I wouldn't go there first unless they gave you a lot of money. And so they do that in some organizations. I've actually heard of situations where they'll give you $1 million in free credits. That's pretty hard to turn down, right? So if they just say, here's $1 million, boom, then I would say, sure, why not? Let's go to GCP Cloud. I mean, they're not as rich in terms of their offerings, but they're functional. You can definitely do similar things, but I would start in that order, as probably AWS first. Azure is close to AWS, and if you're already using it, I wouldn't switch clouds. Like if you're already doing things with Azure, there's no real reason, in my opinion. And then GCP would be, hey, sure, if they give you a bunch of money, why not? Go for it. Let's go to the next question here is, would you be able to automate the creation of multiple virtual environments to test multiple package versions inside of a workflow? Yeah, I think there's a couple different ways that people will do that. It's a great question. So if you wanted to test multiple versions of Python, how would you do that? Test multiple, uh, versions. There are people that, of Python, for example. So there are fancier versions of virtual environment that people use that can manage lots of virtual environments. So you could use, a fancier tool that can do that. I don't personally use those. Two, you could inside of GitHub Actions just actually do the testing, right? Just tell your build server to do the advanced stuff. And so in GitHub Actions, just tell it to test a matrix. And so GitHub Actions has the ability to do matrix level testing of Python 3, 4, 5, 6, 7. I think that's probably the cleanest way to do it. Another way is there's also a library called Tox, which I don't personally use it. I know a lot of people that do use it. And so those are three ways that you could test that out. I work with secret data for defense work. Do you think the cloud-based solutions are safe enough for secret in terms of coding and testing as what you just showed us? Yeah, I think that's a great question. So let's get into that real quick. So in terms of secrets, how would you deal with this from a cloud perspective? I would say that they're more secure than a regular environment. And the reason for this is something called the shared security model. And with the shared security model, you're offloading essentially a part of a pyramid of work to the cloud provider to do things better than what you probably can do yourself in your organization. So, for example, in this layer of the pyramid, they're doing things that you probably don't want to do as an organization. So, the data center itself, right? They're doing best practices, and they're handling the operational level security. They're also handling things like OS level patches, right? And they're handling those kinds of things. So you, on your side, if you, for example, do end-to-end encryption, and you're also doing PLP, principle of least privilege, really they couldn't get your data because it's encrypted end-to-end and only the right people have access to it. So you're building on top of already a more secure foundation than you could build yourself. So I would say yes. In the case of government, you're actually better off using a cloud provider that has very strict auditing and compliance and resources to do this. Okay, next question. You make all this look easy due to your familiarity. Which services do you think are the least amount of time to learn, and which is the most feature rich, and which is the most balanced? So for me, I would say to me, we'll call this again the golden path would be that. To me, the golden path would be that I would focus on, and we can say this is like the lava pit 1, the lava pit 2 here, that you don't want to go to those lava pits would be, I would build functions in Python like we just went through. I would use AWS Lambda, and I would do Flask, which is for web services, and I would use Click, and then I would use GitHub Actions. I think that is the highest ROI. And I know this because I have students that do these things and they really quickly pick these things up. I would focus on this. I would focus on these things: GitHub Actions, functions, AWS Lambda, Flask, Click, and just stick with that. And if you can build almost anything by just using those building blocks. And when should we use containers and Kubernetes? Should we also get familiar with Terraform? Yeah, I think Terraform is okay. Like that's not a bad service. If you go again to this MLOps cookbook, I don't have time. I didn't have time to get into this, but notice that this is actually essentially a soup to nuts from container version of what we did. And it just adds a slight layer of complexity to it. And you can see here, this is what it looks like. But I think containers are helpful in that it adds a little extra protection, and that you can build out lots of different solutions. For example, like you can, go through here and invoke in this example, you can build out services, you can build out local testing for it, you can deploy it to all these different environments if you containerize it. And in particular, when you containerize it, you can actually run it. Anybody can run your code, like this example. Anybody can run your code without having to do any installation. So it just adds a little bit more extra polish. If you want to see like a fairly real world example of that, again, go to that Python MLOps cookbook. Now, Terraform, to answer your other question, I think that's useful when you're doing infrastructure as code, so that you're not only automating the testing, but you're also making sure that the infrastructure is deployed itself. So yeah, Terraform or AWS has CloudFormation or SAM. Anything that can define the infrastructure ahead of time and automate that is a really a best practice that I would recommend. Next question here is, how would you best correlate different applications from different dev teams to be able to mesh together the app data and report metrics, be able to see what broke and affected dependencies? Yeah, so for coordination, I think this is really where you want to have to do monitoring, at scale. I think that the key things here are, you must log your code. So that's a requirement. You need to have a centralized logging server. And so the centralized logging server on AWS is called CloudWatch. And then you could create dashboards. And then I also would have load tests that are fairly frequent, maybe weekly load tests or daily load tests, where you can see the full integration of the system at once. And then you're able to verify that all of the pieces work together. And if all of this should be 100% automatic. And if you do, then you can have a fairly robust system. And this is actually something I teach in the courses at university. Is there people in a, let's say, a cloud computing course, they build at the end an application that has logging, it has a centralized search mechanism, and then also there's an automatic load test. And so these three characteristics, I think, are the key. Okay, great. Well, I think I was able to get through all the questions. Again, thank you, everybody. If you want to connect LinkedIn, happy to connect LinkedIn. A lot of the stuff I'm working on as well, you can get on my website. Also, GitHub. I'm fairly prolific here on GitHub. I try to create stuff almost every day. There's lots of stuff there that you can take a look at. But yeah, it was a pleasure working with you. I can stop sharing and maybe turn this over to Chris.
All right. Well, thanks a lot. Yeah, no, awesome boot camp again today. Thanks everybody for coming out and sticking around again. Just a reminder too, if you have a few moments, we'd love to know what you think. I have posted the link to the survey in the chat again. So again, we appreciate that 5 minutes or so it takes to fill that in. So that's pretty much it for our end. Thanks a lot. Do look for the recording though, that will be posted probably at least by morning tomorrow. So if you want to watch the replay for this class, or if you need to go back and go over something again, that'll be there for you too. So yeah, thanks again, Noah, and we appreciate everybody coming out. So please take care and stay safe.
Talk to you later.
All right, bye.
Thank you, everybody.